Hello everyone. What I'd like to do now is show you how to use dummy coding to conduct a multiple regression analysis. For your week 8 assignment, we'll be looking at performance and how anxiety levels affect task performance. And in this case, we have 3 levels of anxiety. Level 1 is low, level 2 is moderate, and level 3 is high anxiety. And so what your assignment asks you to do is use multiple regression to compare the low and the moderate anxiety groups to the low and high anxiety groups to the moderate anxiety groups. So the moderate anxiety group is going to be your reference group. So the way we'll start out with coding this is that the low anxiety folks for this dummy variable will all get ones. Our reference group will get zeros. That's the moderate group. And because we want just the low anxiety folks for this column, the high anxiety will also get zeros. Our second column, we want this to be the column that represents the high anxiety group. So the low anxiety folks are going to get a 0. And because this is our comparison group, by default, we'll get the information from that. And I'll explain that to you after I run the analysis. But we'll give them zeros as well. And then for this group, the high anxiety group, they're going to obtain ones. And so what I'd like to do is I'm going to run the explore analysis before we do the regression analysis. So I'm going to come here and go to descriptives and explore. I'll reset this and show you how I did that. And I'm going to put performance in the dependent list and anxiety in the factors list. And then I should do the normality plots and the histograms. That way, when you do this, you can examine the assumptions and evaluate those. And then go OK. Now, for this part of the analysis, what I really want to just focus on for this video is you have the low anxiety mean is 68.8. The moderate anxiety mean, or the medium anxiety, which is our reference group, is 86.4. And the high anxiety group is 74.4. Okay, so that's all I want to look at there. Now you can use this information more detailed to write up your description of how this data meets or does not meet certain assumptions for multiple regression. So the next part of the assignment that I'm going to now focus on is running the regression. So now I'm going to come to Analyze, Regression, and Linear. Now again, we want to move task performance in the dependent variable box. And this time we're going to move low anxiety and high anxiety into the independents. Now make sure you have the D1 and the D2 in this independent variables box. Okay. So now for this particular analysis, I think we have everything we want here. We don't really want these statistics at this time because it'll give us different information than what we expect when using dummy coding. So let me run this and we'll go OK. So now you have the output for your regression analysis. We see the multiple correlation coefficient R is 0.738. We square that, R square is 0.54. So 54% of the variability in task performance is being explained by high, low, and medium anxiety groups. In other words, variability among those groups. And we can see that it's explaining this variability beyond chance levels, or it's explaining a significant amount because our probability, or our type 1 error, is below 0.05. Now when we go down here to the coefficients table, our constant is 86.4. Now in this case, when we use dummy coding, the constant represents the mean of the reference group. So if we go back up here to explore all the way up, we see that our medium anxiety group is 86.4, which corresponds with our constant. Now, our low anxiety group means for every unit change in task performance, task performance decreases by 17.6 compared to the medium anxiety group, which is our reference group. So if we take 17.6 from 86.4, our mean for low anxiety, if we go up here, will be 68.8. And you could do that math also. The same way with a high anxiety group. If we take 12 minus 86.4, we're going to get 74 is going to be our mean for our high anxiety group. And so if we go back up here, we see 74.4 is our mean for that group. Okay. So this is how you do the first part of the analysis. Now, one of the issues that the analysis asks you to explore in terms of the assumptions is the linearity of the data. So does anxiety groups, low, moderate, and high anxiety, is there a linear relationship between that and task performance? So one of the things that you can do to check that is you can go to, well actually we should go to graphs. We should go to legacy dialogues and scatter dot. And we're going to make a simple scatter plot. And in this case, on the y-axis we want performance. And on the x-axis, now this is different, we want anxiety. We don't want the low or the high anxiety groups. We just want the anxiety groups combined. And when we do this, then we can go OK. And you can see the scatter plot that's formed here. And this scatter plot seems to, if we look at this, have a curvilinear kind of trend, because you have the data here, there's a high point in the middle, and then it decreases. So we might say for low anxiety groups, this is the characteristic curve here. This is the moderate anxiety group, and this is the high anxiety group. And so what we can do is we can fit a line to this. We can double click in the middle, and we're going to click on this add interpolation line, because what we have is a curved line, not a straight line. And so I really don't want this straight line, but I'm going to click on spline and then apply. And so what that does is that gives me my curved line. And so now you see that I've been able to fit a curved line to represent this data. So in part 2 of the video, then I'm going to show you how to use the orthogonal coding to do a multiple regression for a linear trend and a upside down quadratic trend.